My name is Janusz, and today I will talk about cave mapping. This is first movie from the series for caves. So what you can see here is a point cloud that we are trying to reach from Mandeye system after the survey in the cave. Shortly speaking, once we calculate trajectory with LiDAR odometry step, we have such odometry, and we can see here that it is quite promising, so we can move directly to the step second. So let's continue. So second step is multi-view TLS registration. Okay, so we have this software. Let's load our session. Let's wait a little. When it is loaded, the trajectory is more than 1 kilometer, so loading time is quite long. We have 810 files to load. It's almost done. So in this particular movie I will show you how I do this project from the beginning till end. I did not see this project before, so I will improvise, and I hope I will reach end-to-end solution so you can follow me in your projects. The idea is that we are using our Mandeye system, that it is mountable on the shoulder and can give you opportunity to traverse cave. Okay, so we can see that the final error is not so big. You can see here. Let's make it like this. Let's put some random colors. Maybe we change background to the white one. Okay. So you can see that error is not so big. So let's jump directly into manual postgraph loop closure mode. And let's go to the end. Oh, you can see that my colleague was climbing this very nice system that can give you opportunity to climb certain levels. Okay, so let's put everything up. So this is the final error. So it is like we can see, we have to find some error on the rotation and translation. So let's start calculating. We have to find certain intersections and let's optimize. So I am finding, let's say, 187 and 147. Oh, we can see the error is not so big. So we add this edge and we optimize with iterative closest point by clicking several times. So we have our first edge. So let's compute postgraph slam so you can see it is refined. Let's find another one. Maybe this can be interesting. 648 598. Okay, we have some small displacement, so we add edge, we perform iterative closest point several times, and then we compute postgraph slam. Okay, let's add another one. 592 653. Okay, we can see some small displacement, so we add edge, we optimize using iterative closest points. You can see that it is optimized, and such routine inspection and iterative closest point I will repeat till end of this movie. So here we have triangle, very nice triangle of observations. You can see that we visited this place 3 times. So let's start with adding 588, 732. You can see some error, so let's add edge. Let's optimize with ICP. You can see that some routine actions. Okay, so let's compute postgraph slam, and suddenly we have it. Okay, and then 732 and 656. We add edge. We optimize with iterative closest points, and again we close the loop. Okay, and let's continue. Oh, we have another triangle. So we have, let's go up. So we have another triangle of paths. So we have 5, 5, 7, 3 and 5, 5, 3. Okay, so let's add edge, minimize error by clicking several times iterative closest point, and then compute postgraph slam. Okay, and we have also 553 and 740. 740. Okay, we can see some displacement, so we add edge and we perform iterative closest point again. So we compute this one and let's continue. Okay, so let's go further. We have 84, for example, and 766. Oh, we have quite large error here. So let's add edge, but here we will use our Gizmo to find a displacement. I think it is like it's quite challenging. But I think I managed. So let's find final displacement with ICP. Okay, we have final with ICP, and then we can compute postgraph slam. Okay, so we have this one. Let's find another one. Okay, maybe here will be 160, 161, 190. Oh, the error is rather small, so that one at edge. Let's find ICP and then compute postgraph slam. Oh, here is very interesting. 300 and 372. Let's add edge and perform ICP several times, and again we calculate postgraph slam. Okay, maybe here will be very nice. We have triangle here, so it will be 313, 338. So we add edge and again ICP. So you can see that always we try to find some nice spot, and we have to add edge and optimize with ICP all the time the same. Okay, let's go to the end. 784. Okay, we add edge, we make ICP several times to be sure that everything is okay, and then we calculate. I think it will be brilliant to check if our upper entry, how it looks like, 325. Oh, it's very nice loop closure, because we can we can use it. Yes, we can use it. You can see that maybe this one. Yes, I will use this one. You can see here at edge, but now we put 1 meter because we have large error, and we type ICP. It's great loop closure because we have upper level and we have ground level. Okay, let's back to 0.1 the search radius, and then we make ICP, click several times till it is not moving, and then we calculate our postgraph slam. Okay, so let's find maybe other nice spots. Maybe this one would be nice, that we have 194, okay, and we have 182. 182, yes, it is very nice, very promising spot. At edge, we make ICP several times, and then compute postgraph slam. Okay, so let's find maybe other nice spots. Okay, so 377 and 427. Oh, we found some small displacement. Let's add edge. Let's make ICP and then compute postgraph slam. Or maybe something in the middle. Oh, we traverse 3 times in the same place, so the same passage. So we have opportunity to use this to make it very, very accurate solution. Okay, and the last one we have 432, 430, maybe 34. Let's add edge and again ICP and compute loop closure. Okay, do we have something more interesting? Maybe this one, 64 and 776. Add edge and compute ICP. Then compute all. Okay, so we have, oh, maybe we can have 790 and 34. Oh, this is very nice. So we add edge and perform ICP. And then that's all. Do we have something more to investigate in this particular project? Oh, I can see some suspicious places in this particular spot. So we have let's say 95 and 113. Oh, we have very nice spot. Let's add edge, perform ICP, and then postgraph slam. Or maybe we can add this one also. 5, 4, 7 and 7, 5, 1. Add edge and ICP. You can see that we can decrease the error from decimetric to centimetric. Okay, so now we save the session as a session loop closure, and then we save the session. It looks very promising. Let's make an inspection on this particular, let's say, stage of the calculations. Still, you can improve it later on, but maybe it will be the topic for next movie. So let's export data and let's check what we have so far. So we can save all marked scans to LAS. Okay, so we have all down sample 01 las. Okay, so we are saving, and we have this cave. All okay. Let's open CloudCompare. Apply all. So we have 28 millions of points, but my comment is that it is not all points. I encourage you to study all movies, how to export data in full resolution, or how to refine in normal distributions transform. But this movie is about how to make your data aligned using loop closure. So let's change into different color from GPS time to intensity. GPS time is the time of acquisition. It's the name of the feature of the point. So if you have GPS connected, then it will be a true time, but here is then just consecutive time. So from gray we go to high contrast, and you can see high contrast, and let's investigate maybe some intersection. Let's make some intersection that will help us in justifying if we did correct job. So maybe, okay, so maybe like this. Oh, the intersection looks promising. So it is sufficient. Several minutes of work. Maybe this intersection would be very sufficient. Oh yeah. It looks also very promising with centimetric accuracy. So let's publish this movie, and let's hope that it is sufficient for caves. So thank you very much, and enjoy using Mandeye in caves. Ciao, ciao.